Right, so let me tell you what goes on in my head when I look at this kind of question, 96, right? But to calculate the mass of NaN3 required to yield 50 liters of N2, and they've given us density of N2. So what I do first is I would say density equals mass over volume. So if I already know the density and I know the volume, 50 liters, I can get the mass of N2 that I want to produce. Then mass divided by molar mass is number of moles, so it means I can get the moles of N2. Then I'll look at the equation and I'll be like, proportion should be able to tell me the number of moles of NaN3 that should react with it, that should produce that. Then after getting the number of moles, I can then get the mass. Yeah, so that's how it happens in my head. Okay, so now let's put it on paper, shall we? Density of the N2 is equal to mass divided by volume. It means that the mass of N2 that they want me to produce is density multiplied by the volume. Do you get what I'm doing here? I've not done anything serious. I just wrote the relationship between density and mass. So yeah, let's move on. 1.25 grams per liter multiplied by the volume, which is 50 in liters. This cancels this, so you know you're doing the right thing. 1.25 times 50, what is that? 1.25 times 50 should give us about 62.5 grams of N2. Okay. N2 has a molar mass, right? What's the molar mass? 2 multiplied by N, so that should be 28 grams per mole. That would mean that the number of moles I'm dealing with here is mass divided by molar mass, yeah? And that would just be 62.5 divided by 28. Okay, we're going stepwisely. If you're lost at any point, please let me know. And then this gives us 2.232 in moles. That's the number of moles of N2 that they want me to produce, right? So I need to figure out the amount of NaN3 that should do that for us. Right, so proportion tells us that 2 moles of NaN3 produces 3 moles of N2. So that would mean that if I have 2.232 moles of N2, I can tell that it should give me 2.232 times 2 divided by 3 moles of NaN3. So that will just give us 1.488 moles of NaN3. Okay, it's going well. Then, after this, I need to get the mass of NaN3. So the number of moles is mass over molar mass, and that means that the mass is number of moles times molar mass. So that becomes 1.488 multiplied by the molar mass of that, which is 23 plus 3 into 14. So when you calculate all that, you should have 96.72 grams, and that serves as the mass of NaN3 required to yield 50 liters of N2. Okay. Now, this is nitrogen. Before you go, let's look at this. This right here, that is nitrogen, right? Now, this is nitrogen, but when you have N3 minus, that is the nitride. That's the nitride ion. Okay, nitride from nitrogen. However, if you have N3 minus like this, that's called the azide. Azide. And this one is what? Nitride. Okay? Just like you have oxide and others. So my question to you is, what would you call this? NaN3, like that. It's different from Na3N. You'd agree, right? These are different things. So my question is, what would you call this? What is the name of this? This is the clue I've given to you here. That's the clue. So tell me what's the name of NaN3. I've been trying so hard not to say the name because I want you to tell me. All right, and I'll see you on 97. Take care. Bye bye.